This is a really great problem to study. It's problem number 48 on page 102. And so let me zoom in on it so you can see it out of the book here. But it says two crates of mass 75 kilograms and 110 kilograms are in contact and at rest on a horizontal surface. A 620 Newton force is exerted on the 75 kilogram crate. If the coefficient of kinetic friction is 0.15, calculate the acceleration of the system, and B, the force that each crate exerts on the other, and then C, repeat with the crates reversed. Okay, so we'll start off with using the 5-step procedure that we use for force. And let me zoom back out a little bit. Given. Got a tabletop. I'm just going to draw it as a horizontal surface. We have a crate of 75 kilograms. We're going to call this crate 1. And then crate 2, a little bit heavier, at 110 kilograms. So this is crate 2. It says it starts from rest. So I just put V naught equals 0. And then we have a 620 Newton applied force. So FA equals 620 newtons. And that's it. That's all that's given. Oh, except I forgot. Mu equals 0.15. Is that right? No. And then we want to find, for part A, we want to know what is the acceleration. And for part B, we want to know what is the force that each crate exerts on each other. So I'm going to put the force of 1 on 2, and then for part C, we want to what is the force of 1 on 2 if 1 and 2 are reversed. That is, we switch the order of them. Okay, so let me zoom out. Okay, so let's solve it. Now, of that 5-step procedure, remember, given, find, and solve with a sketch of the problem. The next part is to draw a free body diagram. In terms of the acceleration, since the two crates are moving together, I'm just going to treat it as one mass. So to draw my free body, I'll just do something like this. And I'll combine the mass and just say that we've got the force of gravity right here, mg. And this will have to be the combined mass. And then, of course, we have a normal force. And then we have this applied force of 620 newtons. And then we'll have a friction force like this. And these are all the forces acting. Gravity, normal force, applied force, and force of friction. There's nothing else going on here. Now, what about this force of 1 on 2? Well, the way I've drawn it here, it's internal to the free body. That is, if the force of 1 on 2 is equal but opposite to the force of 2 on 1. So there's no need to draw an internal forces like that on the free body. We'll get to that in just a minute. We'll get to these forces in just a minute. So I'm going to identify my x direction as being to the right and my y direction as being straight up. So that's step 3. There are no forces that need to be broken up into components, so I can go right to step 4. Let's sum the forces in the x direction equals ma in the x direction. I look in the x direction. I say, okay, well, in the x direction, I've got this applied force, which I know, minus the force of friction, because it's in the negative x direction, equals ma. Okay, and I know what m is. It's the combined mass. So I can solve for a, but I need to know what I need to solve for the force of friction. So we know that the force of friction is equal to mu times the normal force. Now, I could be really thorough and sum the forces in the y direction equals ma in the y direction. Well, there is no acceleration in the y direction, and there's only two forces, so they have to cancel each other out. So this is one of those times where I do take a little bit of a shortcut and just say, oh, okay, the normal force is just equal to the weight. Equals, so the force of friction is equal to mu mg. So now I can take this and solve for A. The acceleration is equal to the applied force, which is 620 newtons, minus the force of friction, which is mu mg, 0.15. And then now the combined mass is 185 kilograms. I think I did the arithmetic right. Yeah. And then G is 9.8 newtons of force for every kilogram of mass. That's how strong gravity is. And then we have to divide it by that combined mass, 185 kilograms. And this should give us, well, let's see. So let's plug this in. I'm going to have 620 minus, and then in parentheses I'll put 0.15 times 185 times 9.8, close the parentheses, equals, and I get 348.05, and then I have to divide that by 185, and I get 1.88, and I think I saw that on your whiteboards, right? 1.88. Okay, and this is all part A. Now for part B, we want to know what are the forces between these two. So now what I'm going to do is this. These are two separate objects, but I combine them into one object when I want to know what the overall acceleration was, because both masses were being accelerated together, so I could do that. But now I want to know, hey, how much does one apply to two? So I'm going to draw a free body diagram of object 2. Okay. And so I've got mg, I've got the normal force, I've got a friction force, but and I also have this force pushing on it. But what is this force right here? Is it the applied force? No. Object 2 does not feel that applied force, not directly. It only feels the force of 1 pushing on it. So I'm going to call the force of 1 on 2. And so now I'll just keep the same x and y axis as I had before. And if I sum the forces in the x direction, equals ma in the x direction. Well, what have I got? I got the force of 1 on 2. Let me zoom in a little bit so you guys can see a little bit better. The force of 1 on 2 minus the force of friction equals ma. Now, I have to be careful. This m is not the combined mass. It's the mass of my free body, which is now 110 kilograms. So I can say, oh, the force of 1 on 2 has to do two things. It has to create acceleration, and it has to overcome the force of friction. Well, what is m? The mass is 110 kilograms. The acceleration is 1.88 meters per second squared, plus the force of friction. Now the force of friction is mu times the normal force. The mu is 0.15. And then the normal force, again, is just the weight. It's just mg. Okay, and now I can solve it. So what is 110 times 1.88 equals 206.8, and I'm going to add to it 0.15 times 110 times 9.8, and I get 368.5. So you guys agree with that? Okay. I'll just, yeah, 368.5. I could call it 0.9, but I'll just keep the extra figure. Okay. Now for part C, you have to and I'll just kind of squeeze part C in over here. They want to reverse 1 and 2. So I'm going to redraw this. (110 kilograms). Now this is 75 kilograms. Now if I think about this, if I combine this, this is really no different than this over here, in that I have to accelerate the same amount of mass. So with the same applied force, that 620 Newton applied force, so the same amount of friction, everything's the same. So I'm going to have the same acceleration. But now I want to know, with what force does 2 push on 1? So I'm just going to do what I did before, but now I'm going to draw a free body diagram of the 75 kilogram crate. And so it's got mg, and the normal force, and the force of friction, and this is the force of, now this is the force of, let's see, this is object 1, and this is object 2. This is a force of 2 on 1, in the way I've drawn it. And if you didn't use the same subscripts that I did, if you use A and B, or however you want to identify it, it's no big deal. And so I'm doing what some of you do in your notebooks that drive me crazy, trying to squeeze it all in. So now if I sum the forces in the x direction, I get well, I have the force of 2 on 1 minus the force of friction equals ma. So the force of 2 on 1 equals ma plus the force of friction. This is exactly like what we did over here. It's really no different. And now the force of 2 on 1 equals ma. Well, now the mass is 75 kilograms. The acceleration is that 1.88 meters per second squared, plus the force of friction. But the force of friction, again, is mu times the normal force, which is mu. So the normal force is just going to be equal to the weight. Look at the free body. So that's going to be plus 0.15 times 75 kilograms times 9.8 newtons per kilogram. So the force of 2 on 1 is equal to 75 times 1.88 plus, parentheses, 0.15 times 75 times 9.8. I got 251. Did you guys get that? Or yeah. 251 newtons. And so let's look at the whole thing. So again, it's just applying that 5-step procedure, one of the most very, very powerful problem-solving technique that we study all year. So it's good stuff. And you know, step 1, give and find solve. Step 2, step 3, step 4, and then this is just the mathy part is step 5. And you'll always get to the answer. I mean, it really, following that procedure, Really helps, especially when you don't know how to solve the problem. Just say, okay, well, I'm just going to follow the steps, and it kind of leads you to the solution. Any questions? Yes?
So was the force, so you calculated the force of 1 on 2, but would the force of 2 on 1 be equal or opposite?
Well, yes. But look, look at this part A. 1 has to push on 2 and get it to accelerate. Well, 2 has got a lot more mass. So that's why you have a greater force. Now, in this object 1 pushes on object 2 with 368.5 newtons of force, right? But object 2 is applying an equal and opposite force to the 75 kilogram mass. So it's applying a 368.5 newton force to the left on object 1. But if you switch these, like over here, this is the big one. It's pushing on the smaller one, so it doesn't need to be as big a force to make it accelerate at the same rate. So, yeah, object 2 applies a force of 251 newtons to crate 1. Now, crate 1 applies an equal and opposite force, a 251 newton force to the left on the 100 kilogram mass. Does that answer your question? Okay. All right, that is all.